Okay, so number 8, part A, B, and C. So it tells us that h of x is the composition of f and g of x. We have g of x getting plugged in as our input for f. So our input for f is right here, it's x. So what we do is we say h of x is going to be equal to the cube root of our input plus 1 plus 4. Our input is x squared plus 2. We just have to combine like terms now. We get the cube root of the square root, the cube root of x squared plus 3. And then we still have the plus 4 hanging out. So that's part A, done. It's part A. Okay, so part B asks us to find the inverse. Okay, so a lot of you will say like, oh, what's this h negative 1 thing? Or we'll just call it h negative 1. Just know that this notation means the inverse of h, the function that's going to undo h. So the whole idea of the inverse is that we are undoing everything that's happening to our input of the original function. So we have we're taking our input and we're squaring it, and then we're adding 3, and then we're taking the cube root, and then we're adding 4. So we have to undo all of that in reverse order. So we're going to end up subtracting 4, we're going to cube the whole thing, and then we're going to subtract 3, and then we're going to take the square root. Okay, so the first thing we do, like the way that we decide to undo everything, is we say x equals the cube root of y squared plus 3 plus 4. So what we're going to do is we're going to solve for y, because that's going to undo everything that's happening to our input, and that'll give us our inverse. So we have x minus 4 equals the cube root of y squared plus 3. And now we have x minus 4 cubed equals y squared plus 3, and then we get x minus 4 cubed minus 3 equals y squared, and then finally we get y equals the square root of x minus 4 cubed minus 3, and that is equal to h inverse of x. We found our inverse. Great. And then part C asks us for what x value is h of x equal to h inverse of x. So we're saying for what input x will we get the same output for both our inverse and our original function. So this is the thing where we have to, we're setting them equal to each other, and we could try to solve it algebraically, but it's going to not end up being a whole number and not being so nice. So what we're going to do is we're going to plug these into a calculator. So we'll hit our y equals button, and then we'll plug in both functions to y1 and y2. Okay, then graph them. You may have to adjust your window. I think for this one it's best to have y equals negative 10 to 10 and x equals negative 10 to 10. And then 3, hit second, trace, which is gives you the calc button, and then hit, from there, hit intersection. Okay, sorry, this is a little messy. 4. Alright, so then for number 4, you're just going to, it's going to ask you first curve. Make sure your cursor is on one of the graphs, and you just hit enter. And then second curve, question mark, and make sure that the cursor is on the second graph, and you hit enter. And then it's going to say guess. and you say enter, and it gives you the x value for which the output of the original function and the inverse is the same. So I think in this case, we did this one in class the other day, but what I think we get is that when x is 8.09, h of x equals 8.09, and also h inverse of x equals 8.09. Okay, so we notice that the input is the same as the output, and that makes sense because remember, the original function sends an input to an output, and then the inverse sends that output back to the input. So if they're going to be equal, then the input and the output must be the same for that to happen. Okay, so that makes sense. So that's a good way to check if you get a problem like this and it says where the inverse and the original function equal to each other. If they are equal to each other, the input should be the same as the output, and that's how you know that you have the inverse. Okay, so that's all for that problem.